Today we are going to start the new chapter, that is derivatives chapter. First we are going to learn a few synopsis points and then we will go to multiple choice questions. So actually the definition of derivative of a function is dy by dx. dy by dx is limit of f of x plus h minus f of x by h as h approaches 0. But if you are given a function and a point, say x equal to a, then the derivative of the function is dy by dx equal to limit of f of a plus h minus f of a by h as h approaches 0. But there is an easy form for derivative for the function at x equal to a, and that is dy by dx equal to limit of f of x minus f of a by x minus a as x approaches a. The first formula is purely the derivative of the function, but the second formula is used to find slope of the function at x equal to a or slope of the tangent drawn at x equal to a. So these two formulas are the formulas to find the slope of the function or slope of the tangent at x equal to a. But in case of a special function called absolute value function, if the function is absolute value of x by x, mod of x by x, it is a piecewise function. If x is greater than 0, mod of x is x and by x, so which is equal to 1. If x is less than 0, mod of x is negative x by x, which is negative 1. But if x is equal to 0, the function will be undefined. For x equal to 0, the function is undefined. In such case, when you find the derivative of the function, it is also a piecewise function. Derivative of 1 will be 0, which is for x greater than 0. Derivative of minus 1 is also 0, which is for x less than 0. And for x equal to 0, the derivative does not exist. How a function can be differentiated? How a function is differentiable? How a function is not differentiable? A function is said to be differentiable when first thing is the derivative has no denominator. It is differentiable everywhere. That means if the derivative has denominator x minus a, then when x minus a is 0, that is when x equal to a, the function is not differentiable. Similarly, second case, when the function is differentiable everywhere, when the derivative has no square root. That means if the derivative has square root, then for x minus a greater than 0, that is for x greater than a, the function is differentiable. Otherwise, the function is not differentiable. The third case is when the derivative has no logarithm, the function is differentiable everywhere. For example, if the derivative has log of x minus a, for x minus a greater than 0, the function is differentiable. Otherwise, it is not differentiable. Now, if at all the function is differentiable, the function has no modulus. That means if the function has mod of x minus a at x minus a equal to 0 or at x equal to a, the function is not differentiable. Everywhere else, it is differentiable. So these are the conditions. In graph, whenever the function has sharp corner, at sharp corners, at sharp turns, at cusps, at discontinuities, the function is not differentiable. At all these places, the function is not differentiable. You can't find the derivative. Sharp corner like this, sharp turn like this, cusp like this, discontinuity like this. In such cases, the function is not differentiable. And now there are some formulas of derivatives which you have to memorize, which you have to learn. The first one is derivative of x power n x power n minus 1. Derivative of any constant, it is 0. Derivative of constant multiplied to a function. Constant will be same. You can find the derivative of the function. A function when added or subtracted, you can find the derivative of the function plus or minus derivative of the other function. Derivative of a power x log a. Derivative of log x base a, 1 by x log a. Derivative of log x base e, 1 by x. Derivative of sin x cos x. Same way, I will be writing some more functions and derivatives here. Derivative of cos x minus sin x. Derivative of tan x secant square x. Derivative of cot x minus cosecant square x. Derivative of secant x tan x. Derivative of cosecant x minus cosecant x cot x. Derivative of sin inverse x, 1 by root of 1 minus x square. Derivative of cos inverse x minus 1 by root of 1 minus x square. Derivative of tan inverse x, 1 by 1 plus x square. Derivative of cot inverse x, minus 1 by 1 plus x square. Similarly, some more functions and derivatives. Derivative of secant inverse x, 1 by mod x root of x square minus 1. Derivative of cosecant inverse x, minus 1 by mod x root of x square minus 1. Derivative of mod x by mod x, but remember x should not be 0. Derivative of step integer function, it is 0 if x is not an integer, but if x is an integer, then the derivative does not exist. Derivative of u dash v plus uv dash. Derivative of u by v, u dash v minus uv dash by v square. Derivative of 1 by x minus 1 by x square. Derivative of root x, 1 by 2 root x. Apart from that, derivative of f of u, f dash u times u dash. This is called chain rule. Derivative of x power x into 1 plus log x. So these are the derivative formulas. Apart from that, some trigonometric formulas are also used in calculus. One is sine square theta plus cos square theta is 1. Secant square theta minus tan square theta is 1. Cosecant square theta minus cot square theta is 1. Sine of alpha plus beta is sine alpha cos beta plus cos alpha sine beta. Sine of alpha minus beta is sine alpha cos beta minus cos alpha sine beta. Cos of alpha plus beta is cos alpha cos beta minus sine alpha sine beta. Cos of alpha minus beta is cos alpha cos beta plus sine alpha sine beta. Tan of alpha plus beta is tan alpha plus tan beta by 1 minus tan alpha tan beta. Tan of alpha minus beta is tan alpha minus tan beta by 1 plus tan alpha tan beta. Cot of alpha plus beta is cot beta cot alpha minus 1 by cot beta plus cot alpha. Cot of alpha minus beta is cot beta cot alpha plus 1 by cot beta minus cot alpha. Sin 2 theta is 2 sin theta cos theta. Cos 2 theta has three formulas: cos square theta minus sin square theta, 2 cos square theta minus 1, 1 minus 2 sin square theta. Formula for sin 2 theta is another formula that is 2 tan theta by 1 plus tan square theta. Formula for cos 2 theta is 1 minus tan square theta by 1 plus tan square theta. Cos theta minus sin theta by cos theta plus sin theta is 1 minus tan theta by 1 plus tan theta, and this can be written as tan pi by 4 minus theta. Cos theta plus sin theta by cos theta minus sin theta is 1 plus tan theta by 1 minus tan theta, and that is tan of pi by 4 plus theta. Now, these formulas can be used to find the derivatives of some function. Sometimes you will be given y equal to tan inverse 2x by 1 minus x square, and you will be asked to find the derivative. So you can put x as tan theta. So you have y equal to tan inverse 2 tan theta by 1 minus tan square theta. So this you can write as tan inverse tan 2 theta. So y will be equal to 2 theta. dy by d theta is 2. Same way as x we have taken tan theta, dx by d theta is secant square theta. So in this way, you can write dy by dx as 2 by secant square theta. That is 2 by secant square theta can be written as 1 plus tan square theta. So it is 1 plus tan square theta is x square. Like this you can do it. Or else the other way to do it is, because y equal to 2 theta, y can be taken as 2, theta is tan inverse x. So dy by dx will be equal to 2 by derivative of tan inverse x is 1 plus x square. Like this also it can be done. Similarly, I'll give you one more example, like y equal to cos inverse 1 minus x square by 1 plus x square, and here also you have to find dy over dx, dy by dx, the derivative. So again you can put x as tan theta. So y will be equal to cos inverse 1 minus tan square theta by 1 plus tan square theta. So y will be equal to cos inverse. You can write this as cos 2 theta. So y can be written as 2 theta, as we have done in the previous page, the same like that. So y equal to 2, theta can be written as tan inverse x. So dy by dx will be equal to 2 into 1 by 1 plus x square. That is 2 by 1 plus x square. So these trigonometric formulas can be used in these cases. The next is parametric differentiation. If you have a parametric equation x equal to f of t and y equal to g of t, then dx by dt will be f dash t, dy by dt is g prime of t. So dy by dx will be equal to g prime of t by f prime of t. This one problem of this kind I'll tell you, like if x equal to 80 square and y equal to 280, you can write dx by dt is a is a constant, t square's derivative is 2t. Similarly, dy by dt, 2a is a constant and t's derivative is 1. So dy by dx will be 2a by 2at, 2a cancels, 1 by t. Similarly, one more problem like this also you can face. X is a into cos theta plus sin theta, y equal to a into sin theta minus theta cos theta. Or instead of cos theta plus sin theta, I'll give you cos theta plus theta sin theta. Something like this. So you can find dx by d theta. A is a constant. Derivative of cos theta is minus sin theta plus. Now we use product rule here. Theta's derivative is 1 into sin theta plus theta into sin theta's derivative is cos theta. So these two cancel. You will have a theta cos theta. Similarly, dy by d theta is a is a constant. Sin theta derivative is cos theta minus theta's derivative is 1 cos theta, and then theta will be same. Actually, there is a minus here. Even though it is product rule, the minus comes here. But because cos theta's derivative is minus sin theta, here we have minus sin theta. Cos theta cancels, a into theta sin theta. So dy by dx will be a theta sin theta by a theta cos theta. A theta will cancel and tan theta will be the answer. Sometimes you will be asked to find differentiation of a function with respect to another function. For example, you will be asked to find differentiate e power x with respect to sin x. Then what we will do is we will take y equal to e power x and we will take z equal to sin x. That means we have to find dy by dz. That is what they mean. So dy by dx is derivative of e power x is e power x. You can write this also in the list of formulas. The derivative list of formulas, I did not give you this formula. Derivative of e power x is e power x. And dz by dx, derivative of sin x is cos x. To find dy by dz, you have to take e power x by cos x. So this is another way. Sometimes you may be asked to find the derivative like this. Or something like this also the question may be. Differentiate sine inverse root of 1 minus x square with respect to cos inverse 2x square minus 1. That means you will take y as sine inverse root of 1 minus x square and z as cos inverse 2x square minus 1, and your work is to find dy by dz. So in both the cases, x we can put it as cos theta. So y will be sine inverse root of 1 minus cos square theta. That means y equal to sine inverse root of sine square theta. That is y equal to sine inverse sine theta, or y is equal to theta. Theta can be written as cos inverse x. So dy by dx is minus 1 by root of 1 minus x square. The same x equal to cos theta if I use for z, then I will have 2 cos square theta minus 1. So z is cos inverse of cos 2 theta, or z is simply 2 theta, where 2 theta is cos inverse x. So dz by dx will be 2 into cos inverse x derivative is minus 1 by root of 1 minus x square. So dy by dz, which we have to find, is minus 1 by root of 1 minus x square by minus 2 by root of 1 minus x square. Minus cancels, root of 1 minus x square cancels, and left is just 1 by 2. So that would be the derivative. Sometimes, whenever in the function the base is having x and the power is also having x, we have to use logarithms to find the derivative. Because when you use log, the power comes outside according to properties of logarithm. When you take log on both the sides, sin x will come outside, and then you can find the derivative. Log of y derivative is 1 by y, but you have to write dy by dx, that is implicit differentiation. And here we will use product rule. Sin x derivative is cos x into log x plus sin x will be same, log x derivative is 1 by x. So dy by dx will be y into cos x into log x plus sin x by x. If you want, you can replace y by the question x power sin x into cos x into log x plus sin x by x. This would be the final answer. But when you take logs, you must remember that log of f of x plus g of x will not be equal to log of f of x plus log of g of x. Never make this mistake. Similarly, log of f of x into g of x will never be equal to log of f of x into log of g of x. In fact, log of f of x into g of x will be equal to log of f of x plus log of g of x. And log of f of x by g of x will be equal to log of f of x minus log of g of x. Similarly, log of f of x power g of x, the power g of x will come out and it becomes log of f of x. So, why I'm telling you this is because sometimes in the question you have x power sin x plus sin x power x. So, for both, the bottom is x and the power is x. The base is x, the power is x. So actually, to find the derivative for both the functions, you have to take logarithms. But don't take combined logarithms for both. You take them as two functions. Like you take u as x power sin x, take v as sin x power x, find the derivative separately. Like you write this as u, this as v. Later on, when you find dy by dx, you can find du by dx separately, dv by dx separately, and add. Like when you want to find du by dx, you have to take log here, take log on both the sides. When you want to find dv by dx, take log on both the sides. Log v equal to log of sin x power x. And as I did in the previous page, find the derivative for both separately. Later on, you can put it here and add it. But don't take a combined logarithm for both. In the same way, suppose y is given as a determinant p, q, r, u, v, w, l, m, n. And you have to find the derivative of the determinant. Then you will be taking dp by dx, dq by dx, dr by dx. Whereas u, v, w, l, m, n you will write same. With that, it doesn't end. You have to add here. You will keep p, q, r same. And now you will find du by dx, dv by dx, dw by dx, whereas l, m, n will be same. To this you will add, you will keep p, q, r same, u, v, w same. Later on dl by dx, dm by dx, and dn by dx. You will write. So this is how you will find the derivative of determinant. Now, not only the first derivative, you can find second derivative, third derivative, successive differentiation is possible. And there are formulas for a few things. Like first, if y is equal to ax plus b power m, you can find the nth derivative, and that will be m into m minus 1 into m minus 2 into m minus n plus 1 into ax plus b power m minus n into a power n. Remember, m is an integer. But if you want to find mth derivative, it will be m factorial into a power m. If you want to find m plus 1th derivative, it will be just 0. Similarly, if y equal to 1 by ax plus b, then the formula for nth derivative is minus 1 power n into n factorial into a power n by ax plus b power n. Then if y is equal to log of ax plus b, then the nth derivative will be minus 1 power n minus 1 into n minus 1 factorial into a power n by ax plus b power n. Similarly, y equal to sine of ax plus b. Then the nth derivative is a power n sine of ax plus b plus n pi by 2. And if you have y equal to cos of ax plus b, then the nth derivative will be a power n cos of ax plus b plus n pi by 2. Apart from this, in derivatives, there are some shortcut formulas also. We will be learning the shortcut formulas also because they will be very much useful. So I will be telling here some shortcut formulas. You can take a note of it. After this page here, here we will go. I will give you some functions column and derivatives column separately. For example, cos power nx into cos nx, n cos power n minus 1 x into cos of n plus 1 into x. Next, sine power nx into sine nx. So the derivative will be n sine power n minus 1 x into sine of n plus 1 into x. Then cos power nx into sine nx. So the derivative will be negative minus n cos power n minus 1x into sine power n plus 1x. The next is sine power nx into cos nx minus n into sine power n minus 1x into cos of n plus 1x. Not only these, of course, to memorize all these, it will be very difficult. If you do the problems and use this, then it will become useful. In few days, you will easily memorize. F of x power g of x. Actual method is, I told you, you will be finding logarithms. You will be using logarithms. But the shortcut method is f of x power g of x into g of x into f prime of x by f of x plus g prime of x into log of f of x. Similarly, if there is a variable power another variable, then you have to find derivative of variable power constant. First you have to find the derivative, plus you have to find the constant power variables derivative also. Similarly, seventh, if you have f of x power f of x, then the derivative will be f of x power f of x into 1 plus log of f of x into f prime of x. This is the formula. Next. Before going to the next, I want to give you one example. Just one question we will do. Like, so that you will understand the formulas. Suppose if you have y equal to x power x, then what will be the derivative? It will be x power x into 1 plus log of x into derivative of x, that is 1. So it will be just x power x into 1 plus log x. But suppose if you have to find derivative of x power y, what will it be? You'll have x power y into the one which I told you above. First you will write y into next derivative of x1 by x itself, then plus derivative of y, that is dy by dx into log of x. This formula also I told you. One more thing, suppose if you have to find derivative of x power sine x. So just now I told you variable power variable. So how will you find? You will find the derivative of variable power constant, right? That means x power sine x plus you will find the derivative of sine x power x. This also you will find. Is that clear? How? Like, one we are treating as variable, the other one as constant. Suppose this is variable, this is constant. This is constant, this is variable. So how will you do when you have a variable power constant? You will take sin x into x power sin x minus 1, variable power constant, like x power n x power n minus 1. Then next, when you have constant power variable, so what's the formula I told you? Constant power variable. Just now we have discussed constant power, like a power x, like a power x. What will you do? You will write a power x as it is, isn't it? So x power sin x, but you have to write log x and then sin x derivative cos x. So like this you have to find. If you think you are getting confused with this, you need not learn this. This is slightly confusing. You can take logarithms and on both the sides and do it. I just told you the method. Those who follow, they can do it, and those who did not follow, they can use the long method only. Only this shortcut method is slightly difficult, as I told you. Okay. Next, we will take some more shortcut methods. Like if you have f of x power y, how to find the derivative? You will have y square into f prime of x by f of x into 1 minus y log of f of x. Or you can write y square into f prime of x by f of x into 1 minus log y also, in short. Then if you have root of f of x plus y, then to find the derivative you can take f prime of x by 2y minus 1. Then next, if it is f of x plus 1 by y, the derivative will be y square f prime of x by y square plus 1. Similarly, if you have f of x by 1 plus f prime of x by 1 plus y, then the derivative will be 1 plus y into f prime of x minus y into f double prime of x by 1 plus 2y minus f of x plus f double prime of x. Suppose if you have x power m into y power n, which is equal to x plus y power m plus n, then dy by dx will be equal to y by x. That is the shortcut formula. And suppose if you have to find the derivative of tan inverse of a cos of f of x plus b sine of f of x by b cos of f of x minus a sine of f of x, that will be equal to just f prime of x. Similarly, if you have to find derivative of tan inverse of a cos of f of x minus b sine of f of x by b cos of f of x plus a sine of f of x, then that also will be just minus f prime of x. Next, if f of x plus y is equal to f of x into f of y, Then f prime of A will be equal to k into f prime of 0. The last formula, if x root of 1 plus y root of 1 plus x equal to 0, then 1 plus x whole square dy by dx plus 1 will be equal to 0. So after these shortcut formulas, we can go to the questions, multiple choice questions now. Today we will be able to solve only a few. We don't have much time, but tomorrow in the next class we will be doing more problems. Let us take the first question. Y is equal to e power x plus 1 by e power x minus 1. You have to find y square plus 2 plus dy by dx equal to. So first we will find dy by dx using quotient rule. So according to quotient rule, we have e power x into e power x minus 1 minus e power x plus 1 into e power x by e power x minus 1 whole square. So you can take e power x common. You'll have e power x minus 1 minus e power x minus 1 by e power x minus 1 whole square. You can cancel e power x. So minus 2 e power x by e power x minus 1 whole square will be there. Now they are asking you to find y square by 2 plus dy by dx. So y square means e power x plus 1 whole square by e power x minus 1 whole square by 2. And then plus dy by dx minus 2 e power x by e power x minus 1 whole square. So that means you will have denominator 2 into e power x minus 1 whole square. So numerator will be e power x plus 1 whole square minus 4 into e power x. So this is same as one formula. What is that formula? I will write here. If you have a plus b whole square minus 4ab, it will be nothing but a minus b whole square. So you can write this as a minus b whole square by 2 into e power x minus 1 whole square. Cancelling this, the final answer is 1 by 2. Coming to the second question. Y is equal to x tan x by 2. Then you have to find 1 plus cos x into dy by dx minus sin x equal to. So first I will find what is dy by dx using product rule. That is 1 into tan x by 2 plus x into secant square x by 2 into 1 by 2. Okay, so now when I take 1 plus cos x into dy by dx minus sin x, I will be having a few things which I have to simplify. Like I will write 1 plus cos x, but when I write dy by dx, tan x by 2 I will write sin x by 2 by cos x by 2. And then plus x by 2 into secant square I will write as 1 by cos square x by 2. And then I have minus sin x. So 1 plus cos x I can write 2 cos square x by 2. And denominator I will take 2 cos square x by 2 as the LCM. So that means I will have 2 sine x by 2 and then plus x minus sine x. So 2 cancels, cos square x by 2 will cancel. Now I have 2 sine x by 2 cos x by 2 also when I take common denominator. So that will be sine x plus x minus sine x. Sine x and minus sine x will cancel. My final answer will be x. So with this, we will end our session. In the next class, we will learn more multiple choice questions.